video on acid and base. This corresponds to your 5th lecture in the Intro to Chemistry course. Today I'll be focusing on buffer solution. As a reminder, a buffer solution is a solution in which the pH varies only slightly when you add a small amount of either a base or an acid. A buffer solution is either made of a weak acid and its conjugate base, or a weak base and its conjugate acid. So here's a question for today. You prepare a buffer solution by dissolving 2 grams of benzoic acid and 2 grams of sodium benzoate in 750 ml of H2O. What is the pH of that buffer? Assume the volume of solution is 750 ml. So I'll be dealing this question using the Henderson-Hasselbalch equation. But first, I'm going to write down the reaction equation. So to do that, I'm first going to write the dissociation of the benzoic acid, because it's a weak acid, in water. C plus water goes in a reversible reaction because it's a weak acid to form a weak base and H3O+. Now the second step is to write down the equation for the sodium benzoate, which is a salt, so it's going to form an ionization reaction. And because it's a salt, it's going to fully dissociate into its component, meaning it's going to form Na, sodium, and a conjugate base, which is the same conjugate base as the one above. Now, because benzoic acid is a weak acid and its Ka value is very small, it's 6.2 times 10 to the power of -5, that means all the reaction will be favored for the product, for the reactants, meaning more of this will be formed, and the concentration of the weak base and the H3O+ is negligible. However, I said that a buffer needs to be made of a weak acid and its conjugate base. Therefore, we're going to take the conjugate base, we're going to add it by taking the salt of it and dissociating in water. This is why we had this reaction equation. So, in reality, what the buffer, what is going to be in that solution is this acid and this conjugate base. So now we're going to have to find the concentration of the conjugate base and the acid. To do that, I'm going to have to find the molar mass of the acid, which is equal to 122.12 grams per mole. Now if I have the molar mass, I can find the number of moles, which is just 2 grams divided by the molar mass, which equals to 0.0164 moles. Now I want to find the concentration, so I simply divide the number of moles by the volume, which is right here, 750 ml. However, we want to find this in liters, so we're first going to convert that as well. And this will be equal out to 0.0218 moles per liter, which can be written as big M. Now we also want to find the concentration of this weak base, since this one is a negligible amount. To find the concentration of this, since it's a 1-to-1 ratio and the reaction goes to completion, we can simply find the concentration of the sodium benzoate. So we're going to do the same thing, find the molar mass. Find the number of moles the same way we did, by dividing it by the mass. And find the concentration by dividing the number of moles by the volume. now that we have the concentration of the weak base and the acid, we can simply plug it back into the Henderson-Hasselbalch equation. However, as you notice, the Henderson-Hasselbalch equation has pKa, and I was given the Ka. Well, I was given it, but you can also find it in your formula booklet. So to convert from pKa to Ka, I can simply use this equation where the pKa is equal to the negative log of the Ka. And this equals out to negative log of 6.2 times 10 to the power of negative 5. And this equals to 4.2. Now I simply have to plug all my values in. The concentration of the conjugate base, which is right here, and of the acid, which equals out, log. When you take the log of this, it equals out to 4.1. And there we go, that's the pH of your buffer. Thank you for watching, and make sure to check out the other videos. Thank you!